technology, really old school technology, 100 plus, 120-year-old technology. And and then secondarily, you know, I mean, they have like super high efficiency compressors made for NASA, made for things like Space Lab and whatnot. And they're like particularly a Danfoss compressor unit for refrigeration device, you know, for refrigerators, freezers, and they run at, you know, something like a third of the power of, like, you know, your best, you know, large side by side. And these refrigerators that are made for the solar industry have, like, you know, 4+ inch thick insulation all the way around them, and they have like the compressors mounted on the top, so all the hot air from the compressors does not like impinge on the cabinet,
right?
And, you know, like get absorbed by the cold stuff inside. And so there's all kinds of tactics like this, such as, you know, like super high efficiency lighting, getting rid of the cathode ray tubes and going to all flat screen monitors and screens that make huge leaps and bounds in efficiency in your appliances that you have at home. And so, I mean, we have basically a toaster oven at home, and we use like an outdoor wood cook stove and an indoor wood cook stove, and that's how we do it. And so, you know, we don't have like an electric range, and we don't have like, you know, an electric skillet and like an electric coffee pot and a microwave and all these things. We don't have any of those things. And so, you know, we don't generally run an air conditioner. I'll run like a dehumidifier if I have to. And so, like, we keep our appliances narrowed down to, like, communications, lighting, some entertainment, you know, stereo. You want to watch videos and stuff from the internet and not be programmed, of course. And, you know, and so where we go is, like, if we want to run electronic devices, we want to get the power from an appropriate source, something that does not cause widespread devastation to our environment, to our health directly, to our pocketbooks by, you know, basically having us on the lifetime payment plan to have lights at night and enjoy, you know, music at odd hours. And so, how do I say? This is one of the better ways I can find to do it, especially in a mobile or temporary setup like this. Something like this is excellent. They can be small. They can be on like little suitcase luggage carts, or like carts for mechanic tool sets work really good because they're able to carry the batteries. And you know, or any other cart you can think of, something that's mobile is good. And if you're going to do it outside, do it with bigger casters than the one we have here is made for in a school or something. And so, you know, a hard floor.
Now you said this solar array up here is the one that's powering the electricity that we were using last night in the tents, right?
Absolutely. That was like, we used that battery for 2 days. We could probably get another half a night out of it. And it takes a good solar day to charge. And so, you know, if we get 2.5 days out of a good solar day, then that's doing pretty good. That's 420 watts on the roof. It's two 185 watt modules and a 50 watt you know, array on the side there. That's two separate systems. The large modules are 24 volts. They can't be wired any less. So they're 24 volt output. So I can stack those to any voltage up to 600 volts, or I can use them at their nominal output, which is 24 volts. So using them at 24 volts through a Trace C40 charge control. It is a pulse width modulated charge control that has 3 modes: charge control, load control, and diversion. It can be used in those 3 modes, only one at a time. And so what they mean is, under load control, you would hook it between your batteries and an appliance, say like a radio transmitter that's unattended, and it would charge the batteries through the pulse width modulated charge control. Or I'm sorry, it would not charge the batteries through the pulse width modulated charge control, but what it would do is it would disconnect the batteries from the load in the event that the voltage of the batteries drop below a certain set point, which is totally adjustable on that control. And so that would be its load control use. It'll handle 40 amps at anywhere between 12 and 48 volts, and so it's field selectable for 12 to 48 volts, and it'll handle 40 amps across that voltage. And so obviously if you step the voltage up, you step the current capacity up, and so the current stays the same, but, you know, doubling the voltage allows more current to flow with less resistance. And so we have a 24 volt and a 12 volt system. The 24 volt system goes through its charge control, which also has a what's called a diversion control, which it'll use the pulse width modulated charge control to charge the batteries. But at any given point, sometimes when there's full power output from the solar modules, the batteries can't accept it at that rate, and so it's just shorting them basically, or switching them on off, like an open circuit, you know, battery circuit, open circuit, battery circuit, like, you know, thousands of times, millions of times maybe. And so I don't know what the exact frequency of that pulse width modulation is, but it's available in the literature. Will take any excess electricity that cannot be switched onto the battery and switch it onto a diversion, which would be like a air resistance heater, or like a resistor air heater, or a resistor heating element for a common electric water heater. So you would take all of what I would particularly do is take all of the excess electricity and shunt it toward a water heater when it can't fit in the battery, and this way you get to keep the heat, and it's
have a different use for it.
Right. And so the 12 volt 50 watt array goes through its down lead into the RV, and it powers these small batteries here that we charge.
Right.
We can charge the big batteries off of it at 12 volts, and what we also do is run the radio station off of it. And so it's got its own charge control, which is like a Morningstar 6 amp sun saver charge control. It has a load control, which will save the batteries again from discharging, and it has temperature compensation. So does the one on the roof. And so as the temperature swings, the voltage, the apparent voltage to the charge controller effectiveness changes over a wide temperature range with the the batteries, lead acid and gel types, all of the sealed lead acid types. And so basically the charge control will be used, and so the next step is an inverter. Right now we have only a 12 volt inverter, so I have to charge batteries on the 24 volt side, 24 volts, and manually rewire the batteries at night, which sucks. Don't do it. And so I would rather have like a 24 or a 48 volt inverter that we can just dump the batteries into and use AC power out. In my particular house system, what I have designed is 24 volt well pumping, 24 volt heat distribution, circulation for domestic hot water, and radiant hydronic heating, and that's super efficient solar industry available circulator pumps. They're DC 12, 24, 48 volt, 3.5, 5, 10, and 20 watt pumps that have no shaft piercing through the pump housing. They're magnetic coupled, the linear current booster built in, if I remember right, and just sweet little silent running, super efficient pumps for moving heat around. And so we would like to bring, I've got 3 4x12 foot solar thermal hot water collectors. They're collectors for solar thermal that basically use water as a heat transfer fluid to bring down into wherever you want to use it for domestic hot water, space heating, process heat, something like that. Hot coffee or something. And so that's later. For now, what we would intend to do is just take water from our storage tank and circulate it through a heat exchanger that's in contact with the wood stove we have inside. This is latent solar heat. We'll use it in its natural battery, which is a log in this case, and convert it to heat, impinge that heat on circulating water to raise the temperature in a storage tank that we then sip off of for things like a radiant hydronic patio at one end of this thing. We intend to flash the inside, or run the ceiling with double bubble foil covered radiant insulating barrier. And so what we'll have hopefully is an easy bake oven inside, where heat shining up from the floor bounces off the ceiling about 80%, maybe a little bit less because of the distance, and then back down to the mass in the room, including the people. So
all of this massive technology and something as simple as a tent.
Right.
Yeah,
he's going to kick the generator on him.
So we're going to be done here for a bit. Thank you once again.
Tools, power tools.
The only last question I had was just that you basically self-educated yourself about this stuff. Isn't that correct?
I was so hungry for information. I couldn't find anything. I realized through research that the solar industry had been blackballed by corporations that had an interest in keeping the lifetime payment plan over us all through utility services, electric, water, whatever. And this is all free energy and free resources that we have. They're abundant.
What was the name of the book?
Oh, there's actually a book out there that is kind of like the Bible for the do-it-yourself and the professional installers out there. It's the Solar Electric Independent Home Book by New England Solar Electric. New England Solar Electric will give you that book for $16.95, or you could get an ebook for $6 or somewhere in the area. I haven't checked the price lately, but it's available as far as I know.
Excellent. The fossil fuels are moving in.
Yeah, smog hog.
Thanks again.